Hey, welcome to PCS EdventuresLab. I'm Justin, and today we're going to be talking about the ultrasonic sensors. Ultrasonic sensors work by emitting a high-frequency sound from the ultrasonic sensors, which bounces off nearby objects and is returned to the ultrasonic sensors. Using the time delay between the signal being sent and the signal being received, the brain is able to calculate how far objects are in front of the brain. Using this, you are able to create programs to use this functionality. When using the ultrasonic sensors, it is of vital importance to plug in the ultrasonic sensor cable in the correct fashion. The red wire connected to the ultrasonic sensor cable must be connected to the VCC label, while the black wire must be connected to the ground label. You can also notice that the front side should always have the silver leads showing. Okay. Here we are in the Cortex under the RiQ user profile. We're going to go ahead and create a new project to use the ultrasonic sensors. So here we've got our main and our end commands. What we want us to do is start out by turning motors A and B on. So we'll drag motor A over here, select motor A and B, and we're just going to turn it on. Now when we're using the ultrasonic sensors, we always want the ultrasonics to be looking for objects in front of it. So to do that, we're going to take advantage of a loop. Now within this loop, we are going to want an if-else statement so that we can say if the ultrasonic sense an object within a certain distance, behave one way, else behave a separate way. So our comparator is going to be this green logic command down here. We can drag it in, and this is what we're going to use to compare our ultrasonic sensor values to some predetermined number. When using ultrasonic sensors, it is very important that we use this sensor command that's labeled use sensor rather than just the general sensor command. This use sensor only works for the ultrasonic sensors, as you see right here, ultrasonic sensor value. So we can drag that into our comparator right here. And now we have an if-else statement that says if U sensor is less than nothing. Right now we need to add a number in there. So we can drag over a number, and the ultrasonics work based off of centimeters. So whatever number you enter here is going to be the equivalent number of centimeters that an object is in front of the RiQ. So for our purposes, let's go ahead and say 20 centimeters. So now our if-else statement says that if the ultrasonic sensor is reading a value less than 20, it will behave this way, else it will behave this way. Let's go ahead and say that if the ultrasonic sensor sees an object within 20 centimeters in front of it, let's have him turn around. To do this, we can set motor A to turn this way. Motor B, we can have turn, motor B only. We can have turn that way. And then we can turn the motors on using the this way and that way command for about half a second. That should be enough time for the RiQ to turn around about 180 degrees. Of course, the number values for time in the Cortex uses tenths of a second, so the number 5 actually represents 5/10 of a second or half a second. Finally, in our if-else statement, if the ultrasonic does not sense an object within 20 centimeters, we want to add in code here to continue driving. So we will add commands here to set motor A and B this way. We need to overwrite the this way and that commands that may have been triggered if there was an object in front of it. And then we will simply turn them on again. So now, if we read through our program, we begin by turning motors A and B on and then entering a loop so that the ultrasonics will constantly be updating. Then we have an if-else statement that says if the ultrasonic sensor reads a value of less than 20, or equivalently 20 centimeters, we will turn motor A this way, motor B that way, and turn them on for half a second. If there is not an object within 20 centimeters, motor A and B will simply run this way and continue running on until an object is sensed in front of the ultrasonic sensors. Okay, now we have the RiQ programmed so that if an object is sensed within 20 centimeters of the robot, it will turn around and head the opposite direction. Let's go ahead and run our program. All right, there we go. Our program works just as expected.